morning friends, and in this video again we are taking control over some of the very popular forms on these integrations and integrals will be solved by method of substitution. So now take some examples and then with the examples only then can be explained. And again I'm telling you that if you want to get command over this, just memorize the formulas. If the formulas are at the tip of your tongue, then you can solve any kind of questions, known or unknown. So now here I have a question which goes like how to find the integration of dx over sine x minus a cos x minus b, sine x minus a cos x minus b. In the previous case we had a sine expression on the top and that was quite suggestive and that was quite helpful, but here we do have nothing. So how will we solve this kind of questions? Now you know that sine a plus b formula goes like sine a cos b plus cos a sine b, something like this. Sine a minus b also has sine a cos b minus cos a sine b, something like that, but we don't have anything in the numerator to find the sine. Now how can you have this? So the suggestion or the manipulation you can call it is achieved like this. Here you see we have x minus a and x minus b. X is variable, a and b are constant. Now what I try to do that, if I take this x minus a and x minus b, you just write like this. Now if I put a minus sign here, then you see that x and x will cancel each other and then you have minus a plus b, that is b minus a. So this is a constant and this is a variable. This is both are same, but this is pure constant and this is a variable because they have x necessarily present there. So what I do that, I'll take sine on both sides. So sine b minus a is sine, and there I'll write x minus a minus x minus b. So it is mean I just want to say that this is just a constant. These two are just constant just because they are equal, and sine b minus a is just one plain numerical value. So in this question, if I multiply sine b minus a up and down, so what I do that outside I'll write sine b minus a, that is just a constant, but inside here I'll write sine x minus a minus x minus b. Now these two terms are same, so it is just a kind of multiplying numerator and denominator of this given rational expression by a constant value, and mathematically this should not change the value of the expression. This is how, and now you can have in the denominator the very same thing as it is. So x minus a sin x minus a and the cos x minus b dx. Now you just expand the numerator because it's in the form of sine a minus b. So what you have? So you have 1 over sine b minus a integration, and then in the numerator you get sine a cos b, sine x minus a cos x minus b minus cos x minus a sin x minus b upon sin x minus a and cos x minus b dx. So here you see now I break this expression into the expression consisting of the two fractions, this upon this minus this upon this, and then I write 1 over sine x minus a. Since I am running little space, that's why I'll try to be a little more direct. So here you say if I write this and this, then sine x minus a will cancel this sine x minus a. So I'll be left with cos x minus b and the cos x minus b again. These two also cancel each other. So what I get? I'll get this 1. So this terms become 1. And then in the next case, this will become tan. So see here I made a mistake because I am not getting anything. Here I am getting 1 and here I am getting cos a over sine means cot and cot, 1 minus cot cot. So this is not going to help me at all. So it means here what I have taken sine, I should have taken cos. So what I need to do that first, so I make this one as cos, this one also as cos, this one becomes cos, this one becomes cos, this one is also cos. Now here you get cos cos, because the formula says we get cos cos plus sin sin. So this is sine. So now this. So even you see in this case that if you do not have the proper substitution, then also you cannot solve the question. Now if I do the same thing here, so I get in 1 times I'll have x minus b getting cancelled, and then I'll have cos x minus a upon sin x minus a, that is cot x minus a. So this is cot x minus a dx plus 1 upon cos x minus a, and then if you divide this by this, then sin x minus a will cancel, and you have sin x minus b upon cos x minus b, that is tan x minus b, tan x minus b dx. Now you just saw that integration of cot x, that is cos by sin, was just directly log sin. So here we can write this as 1 over cos x minus a log mod sin x minus a plus 1 over cos x minus a, and integration of tan is using same cos by sin, but you get negative cos, that becomes sec. So that's log mod sec x minus b, that is log mod sec x minus b plus c, and this is your final answer. So here in this expression you learn that if you do not substitute it properly, see one mistake I made again, this one should be cos, because when I had this sin and I was, even after substitution, I was not getting the proper form so that I can integrate them. So that's why I changed this form from sine to cosine, and now everything is coming so nicely. So this is how the method of substitution is handy, but every substitution cannot give the better result. So let me clear the screen and I take another example just to solve some more. Now here I have one question, which is integration under root 1 minus root x upon 1 plus root x dx. Now this is looking very complicated, but if you remember, there are certain formulas, and if you apply, then you can find the answer. First, if I have root x as something which can give me some better results. So what better result? Like if I say that, you might have seen the formula that 1 minus cos 2x, this is formula I am just writing. 1 minus cos 2 theta is 2 sine square theta, and 1 plus cos 2 theta is 2 cos square theta. So if I take my root x as cos 2 theta, some of the purpose can be solved. So let's see. I say let root x equals cos 2 theta, means x equal to cos square 2 theta. Then what will be the dx? Dx will become 2 cos 2 theta into minus sine 2 theta into 2. How? The answer is how. So let me just explain first how I will get this answer, because this is coming the part of differentiation. So we have x equals cos square 2 theta. What we'll do that, we'll assume it as this is cos 2 theta whole square. So now we are discussing the differentiation here right now, and in this form you see this is differentiation of something like differentiation of x to the power n, that is nx to the power n minus 1. So using this formula, differentiation of x square d by dx of x square is just 2x. So you just take this whole thing as something square, so differentiation of that will become 2 cos 2 theta. 2x means 2 cos 2 theta. Now we have to differentiate this something also. Differentiation of cos theta is minus sin theta. Again, this is not cos theta, this is cos 2 theta. So 2 theta means this is cos something. So differentiation of cos 2 theta will be minus sin 2 theta, and we need to find the differentiation of 2 theta again, that part, and differentiation of this 2 theta is 2. So your answer will be minus 4 sin 2 theta and cos 2 theta. This is very much here. Now I need to clear this part. So what I do that I substitute and my whole thing becomes like this: 1 minus root x, that is this part cos 2 theta, upon 1 plus cos 2 theta, and at the place of dx you can write minus 2 sin 4 theta, because sin 2 theta is 2 sin theta cos theta. Sin 2 theta is 2 sin theta cos theta. So 2 sin, just take minus 2 sin, become the minus 2 sin 4 theta and d theta. Okay. Now this inside the root, this will become under root 2 sin square theta upon 2 cos square theta. I put the minus sign outside 2 also, and then I have sin 4 theta d theta. So minus 2, this 2 to cancel, and square root of sin square theta upon cos square theta will become just sin theta upon cos theta. And here we have the sin 4 theta. Sin 4 theta can be written as 2 sin 2 theta cos 2 theta. Okay, and then you can write this as minus 2 sin 2 theta can be written as 2 sin theta cos theta again. So sin theta 2 into sin theta cos theta and cos 2 theta upon cos theta. So this cos theta cancel. Now you have your expression as this 4 sin square theta and cos 2 theta. Now how will you solve this one? 4 sin square theta and the cos 2 theta. So I need to clear my screen. So I write minus 8, 2 to 4 to 8, and sin square theta and cos 2 theta d theta. Then I write minus 8 sin square theta, and at the place of cos 2 theta you can write 1 minus 2 sin square theta d theta. So this is minus 8 sin square theta d theta plus 16 sin to the power 4 theta d theta. So now here you have these two forms, and these two forms are integrable. Now just after clearing the screen, I will discuss how you can integrate these kind of forms, because your integration right now has become in this form, that is minus 8 sin square theta cos square sin square theta d theta and sin to the power 4 theta. Now how will you solve these kind of questions? Now you have a form of integration which goes like this. It is sin to the power m theta and cos to the power n theta d theta. So you have this particular form and this form have different approaches. First, both m and n are even, then how will you solve? Like if both m and n are even, the form goes like integration sine to the power 4x cos to the power 4x, something like that, or sine to the power 4x cos to the power 6x, something like that. So the powers are even. In this condition, what you can do and how you can solve the question. So there, and another way, it can be both odd. It can be sine cube x and cos to the power 5x, like this. When you have both the powers odd, then how will you solve the question? When you have one is even, sine x and cos to the power 4x dx. When you have this form, then how will you solve the question? When you have sine to the power 4x and cos to the power 5x, then how will you solve the question? When you have sine to the power 5x and cos is 0, then how will you solve the question? When you have sine to the power 0 and the cos to the power 5x, then how will you solve the question? You can have sine to the power 4x, how will you solve this question? You can have sine to the cos to the power 6x, how will you solve the question? So this expression is taking so different various forms, and these questions we can solve one by one. So first I'll go for one form and then slowly in another form, and then we will solve most of these forms. Now how will you solve these kind of questions? So in the very next video I will solve each and every different forms, and then I'll tell you how you can solve these kind of substitution. Thank you very much. Just subscribe to our channel and keep practicing with us.